Hi, my name is Tatjana Farjadi. I am an economics major at UMW, and my research project this semester focused on whether coffee production has any impact on ecosystems' regenerative capacities. So before getting into what regenerative capacities even means, I want to focus on some background on coffee production. So there are two main types of coffee beans produced around the world: Arabica beans, which account for around 70% of global production, and Robusta beans, which account for around 30% of global production. So there is some differences between these types of beans, their quality, the quantity of yields, and their growing preferences. Arabica coffee beans generally prefer a cooler shaded environment, and this means that they're going to be of a much more higher quality, but at the end of their growing cycles, they're going to have a lower quantity of production yield. Robusta beans, on the other hand, are able to thrive in much more sun-exposed, higher temperature environments. However, the quality of these beans are going to be much lower, and at the end of their production growing cycles, they're going to have a much higher quantity of production yields. Somporn and others in 2012 just provide some empirical results to support the general known practices of Arabica coffee bean production in finding that the Catamore bean in Thailand, that its production quality was improved by providing shade during its growing process. And I find it particularly interesting in Central and South American countries to focus on coffee production, as these countries are home to very high varying levels of biodiversity and tropical climates, so this allows for them to produce a much higher level of certain specific goods, such as Arabica coffee beans, than other countries. This means that their GDPs, their economic growth, are going to be highly reliant on such production processes in the long term. So I found it particularly interesting to focus on these countries, as well as the impact of such heightened production processes on the environment. So the more research I did on Arabica coffee production and these shade grown preferences, the more that I found that a lot of prior research focuses on the consequences that shade grown coffee has on surrounding environments. And this is within the name shade grown. So if we examine a situation, shade grown coffee beans, the fact that they need to be protected from the sun. This protection from the sun can be provided by an increased variety in plants, as well as a result of this increase in variety of plants, an increased variety in surrounding animals, insects around this coffee plant. Boctori and others in 2010 find supporting empirical evidence that implementing shade-grown coffee contributes to positive biodiversity impacts, as well as a plethora of other ecological benefits. Deitch and others in 2004 find that when introducing shade-grown coffee in fragmented forest areas, this resulted in an increase in richness in those same areas and surrounding landscapes. And so this led me to my motivation for my specific research question. So first of all, I obviously acknowledge that traditionally Arabica coffee beans are grown in a cooler shaded environment. However, we also have to acknowledge that there have been a lot of fluctuations in recent years and prior decades in the income that growers and farmers receive. This can be seen in examining the impacts of the international coffee crisis in 1989 on the income and growers and farmers received, as well as other shocks that really decreased the income that these growers and farmers received, which, as environmental scientists and economists have analyzed and predicted, this might have impacted their growing practices. And so this might have led them to take Arabica coffee beans out of their traditional cooler shaded environments and place them into more sun-grown environments, which would have sped up their growing cycles to ensure that a higher number of beans could be produced so that they could earn more of a profit and make up for some of that lost income. But however, in that process of taking those coffee beans out of their natural environment, this results in those growers and farmers relying on a lot more pesticides and chemicals to ensure a certain quality of that bean is met. And so this introduces really a whole plethora of consequences on the environment after changing this sort of growing practice that is more traditional and is probably more beneficial to the environment. So I'm essentially putting this relationship with Arabica coffee bean production and shade grown benefits to the environment. I'm putting these relationships in conversation with each other and putting them to the test, examining whether coffee production, specifically Arabica coffee production, has any significant impact, positive or negative, on the environment, and what this might be able to tell us about transitions or not transitions in this traditional growing process of Arabica coffee beans. So what do I mean when I say environmental impacts? So I'm focusing specifically on biocapacity. As you can see on the graph on the right, the ecological footprint is this ever increasing red line, whereas biocapacity is that pretty steady green line. So the ecological footprint we might be more familiar with. This is generally what we're demanding of a current area of land at a specific point in time. Biocapacity, however, is an abbreviation for biological capacity, or how fast an area of land is able to regenerate certain resources and is able to absorb waste. So when countries are focusing on environmental sustainability, they really want to make sure that they're not demanding more than what ecosystems can regenerate, or they want to make sure that their ecological footprint is lower than their biocapacity. Both of these indexes are measured in global hectares, which is a very fancy way of saying biologically productive land, which I already mentioned what that was. But it also has a second meaning, which is that it is an aggregate global unit. So countries with completely different climates, such as Canada and Colombia, can compare these two measures, ecological footprint and biocapacity, without worrying for accounting for difference in climates and temperatures, as these global hectares already account for that. And an example, just to put these indexes into more context, specifically biocapacity, if we think of 2 acres of a parking lot versus 2 acres of forest area, we might think of these as completely equal to each other. However, what biocapacity does is it gives these 2 acres of forest area a higher number of global hectares and therefore a higher biocapacity than the parking lot, because the forest area, even though they're the same number of acres, the forest area is able to generate an ongoing supply of resources and absorb far more waste than the parking lot would be able to. So going over some of the existing literature really quickly before my contributions, I found that prior research focuses really heavily on this reverse relationship. They find that climate change, by examining droughts, temperature increases, etc., are able to or have a very negative impact on the production yields of coffee, finding that certain coffee beans and production yields are highly sensitive to climate change. There's also a lot of prior research which focuses, as I already stated, on the benefits that shade-grown coffee beans have on their surrounding environments. And so this is where my contribution comes into play. As I stated again, I'm putting that relationship between Arabica coffee production, shade-grown environments, and environmental benefits, I'm putting those all to the test. And so to do this, I'm examining a much more macro level question. I'm not just focusing on one Arabica coffee bean. I'm not just focusing on one country. I'm examining all Arabica coffee bean production across 6 countries. I also focus on biocapacity rather than biodiversity, soil richness, temperature increases, or droughts, because I find that when examining a much more macro level question, it's much more beneficial to have a more broad indicator of environmental sustainability. And also, as I stated with that first slide, these countries that I examined, their economies and economic growth are all dependent really heavily on Arabica coffee production. And so I think it's really important to acknowledge indexes like biocapacity, because these hold really important impacts and meanings for the sustainability of those economic processes. So my estimating equation, biocapacity is my dependent variable. Coffee production is my main explanatory variable, and I include meat production, dairy production, and soy production to account for any negative impacts that these production processes would have on biocapacity. I also include forest area to account for any positive impacts that this would have on biocapacity. As you can see, I log almost all of my variables except forest area, which is already included in percentage terms. And I log these variables to make sure that when I'm examining the coefficient estimates, I can more easily understand certain increases and decreases in percentage terms rather than bouncing back and forth between different units of measurement. I also lag all of the production variables, and this is to account for any lagged effect that production in one year would have on production in another year. Because when we think of impacts of production processes on climate change, a lot of times these results are examining a lagged effect and hold predictions for, say, coffee production in one year having impacts on climate change in the next year. This is why I lag all of these variables for 1 year. I also run a fixed effects regression, as you can see by the delta and alpha variables. The delta variable accounts for any change over the time period 1993 to 2016 that might not be observed with the already included variables. And the alpha variable accounts for any change between panel entities Brazil, Colombia, Ecuador, El Salvador, Guatemala, and Honduras, also perhaps not observed by the already included variables. Now, the reason for focusing on this time period is because it honestly allowed for the broadest array of accessible data, ensuring that I could keep my observations at as high of a level as possible. You can also see that the top coffee producing countries do not line up with the ones that I have chosen. Now, I already mentioned this in the first slide that due to their similar climates, the countries that I select are able to produce a very high level of Arabica coffee beans. Furthermore, Vietnam and Indonesia produce almost solely Robusta beans, which differs from the intent of my project to focus on Arabica beans. I also really wanted to focus on Ethiopia, as Arabica coffee growing culture really originated in this area of the world. However, there was a lot of fragmented data when it came to this country, and I wanted to ensure that the number of observations would be fairly high. However, I do include Brazil and Colombia, which are in this top 5 list, along with other countries to ensure variation within my data set. And this is how I will be interpreting the coefficient estimate of the main explanatory variable, the log of coffee production. So this can be interpreted as the percent change in biocapacity when coffee production increases by 1%, holding all other variables constant. As you can see with my summary statistics, I have bolded the dependent variable and the main explanatory variable. Initially they're measured in global hectares and 1,060 kilogram bags. I obviously log both of these variables, as you can see towards the bottom of this table. So my estimation results show that coffee production is not statistically significant at the 10% level and having any impact on biocapacity. Meat production and forest area, however, are both statistically significant at the 1% level. Meat production, this coefficient estimate shows that an increase in meat production actually increases biocapacity, which differs from the predicted value that I had. So I predicted a negative coefficient estimate, and this was relying on a lot of prior research, which showed that meat production has really negative impacts on biocapacity and surrounding environments as a whole. However, the forest area variable has a positive coefficient value, which indicates that an increase in forest area increases biocapacity. And this lines up with my predicted value for this variable. So as I already stated, I cannot say with any absolute certainty whether Arabica coffee production had any impact on biocapacity, but this was the intent behind this research, to really put that relationship between Arabica coffee production and possible benefits to the environment from the shade-grown traditional growing practice. I was putting that to the test. And that was the intent, to focus on a much more macro level question. So I think future research could really focus on comparing different types of coffee beans, different types of Arabica coffee beans, and their impacts on the environment. As I stated before, there is so much prior research focusing on specific coffee beans and only that coffee bean. I think it would be so much more beneficial to put those different coffee beans in conversation with each other and analyze their impacts not only on the environment, but also comparing their production costs to understand which specific Arabica beans are the most efficient yet sustainable to produce. Because as I stated before, those countries who are really heavily dependent on Arabica coffee production, it's not just important to analyze which are the most efficient to produce to ensure the highest profit that can be made off of producing these beans, but also which are the most sustainable. Because if you have economies and the economic growth that's really dependent on these production processes, you want to ensure that those production processes are not imposing really harmful negative impacts on surrounding environments in the long term, which is why I think focusing on measures like biocapacity are so important for future research as well. And thank you so much for watching my presentation.